Is Yellowstone gonna blow?
If this volcano was going to produce something big, you could not hide the signs even if you wanted to.
A cube 6 miles across, deep and high, and that's how much lava came out.
Yellowstone National Park in Wyoming, Idaho and Montana is the oldest national park in the entire world, giving it special significance in geological history. It was one of the first World Heritage Sites in the United States and became a UNESCO World Heritage Site in 1978. Many of its most celebrated natural wonders have remained untouched for hundreds of years. Yet amidst this paradise, an unforeseen event has cast a shadow over the park's future. Brace yourselves, for Yellowstone Park is on the verge of closure, prompted by none other than the ominous warning of the renowned Neil deGrasse Tyson. What is this warning, and what exactly is going on in Yellowstone? Let's find out. Located primarily in Wyoming, but extending into Montana and Idaho, Yellowstone National Park sprawls across a staggering 2.2 million acres. Within its borders lies a treasure trove of extraordinary features that will leave you in awe. Perhaps the most famous of these are the geothermal marvels that grace the park's landscape, with an astonishing array of over 10,000 geysers, hot springs, mud pots, and fumaroles. Among these wonders, the legendary Old Faithful geyser takes center stage, its predictable eruptions a testament to nature's incredible precision. Equally unforgettable is the Grand Prismatic Spring, showcasing a vibrant tapestry of colors that will forever be etched in your memory. Yet Yellowstone has even more to offer. Carved by the relentless force of the Yellowstone River, the park reveals the majestic Grand Canyon of the Yellowstone. Here, towering yellow and orange cliffs frame the rushing river, creating a breathtaking sight that defies description. But beneath the surface beauty lies a simmering terror, the Yellowstone supervolcano. This colossal volcanic system, classified as a caldera, stretches an impressive 45 miles in diameter. The caldera's formation can be traced back to ancient volcanic eruptions that occurred millions of years ago, where unimaginable explosions expelled vast quantities of volcanic material, resulting in the collapse of the volcanic structure and the birth of the caldera we see today. While the presence of the supervolcano might be a cause for concern, the current volcanic activity is a mere echo of the cataclysmic events that shook Yellowstone in the past. And despite the colossal eruption occurring approximately 640,000 years ago, Yellowstone remains far from dormant. The region hums with constant activity, with frequent small earthquakes, persistent geothermal heat, and sporadic eruptions of geysers. Thousands of these minor earthquakes are recorded annually in the vicinity, signifying the continuous movement of molten rock or magma beneath the Earth's surface. Yet these subtle warnings from the Earth should not be taken lightly. Scientists devoted to studying Yellowstone have heeded these signs, recognizing the potential dangers that lie beneath the seemingly tranquil exterior. Armed with sophisticated monitoring systems, they tirelessly collect vital data about the behavior and potential for future eruptions of the Yellowstone supervolcano. By doing so, they strive to unravel the secrets of this geological marvel, ensuring that we are better prepared for whatever the Earth's fiery depths may unleash. Volcanic systems possess intricate complexities, and numerous factors can influence volcanic behavior. Therefore, the continuous monitoring and data gathered play a crucial role in ongoing research, enabling scientists to enhance their comprehension of the dynamics of the Yellowstone supervolcano. Without these efforts, we would be oblivious to the imminent danger lurking beneath our feet, akin to sitting atop a ticking time bomb. During an episode of the Star Talk podcast, astrophysicist Neil deGrasse Tyson and volcanologist Janine Krippner delved into the topic of the potential eruption of the Yellowstone supervolcano, unveiling its distinctive characteristics. The conversation took an intriguing turn as Tyson and Krippner elucidated the nature of supervolcanoes, highlighting their magnitude and impact compared to smaller-scale volcanic eruptions. A supervolcano is defined as one that has experienced a significant eruption in the past, setting it apart due to its extraordinary explosiveness and the colossal volume of magma involved. These super eruptions are classified as VEI8 on the Volcanic Explosivity Index, underscoring their immense power and catastrophic potential. The Volcanic Explosivity Index serves as a standardized scale employed by scientists to gauge and categorize the explosiveness of volcanic eruptions. This scale facilitates the comparison of eruptions based on various factors, including eruption cloud height, erupted material volume, and eruption duration. Ranging from 0 to 8, the VEI scale delineates the varying levels of explosivity, with 0 representing the least explosive eruptions and 8 symbolizing the most violent and devastating ones. Each VEI level corresponds to specific eruption characteristics, enabling scientists to estimate the intensity and impact of an eruption. The scale takes into account parameters such as the height of the eruption column, the amount of ejected solid volcanic material, or tephra, and the duration of the eruption. These factors are typically determined through field observations, satellite imagery, and the analysis of deposits left behind by previous eruptions. At the lower end of the scale, VEI2 eruptions are relatively modest and confined, causing limited effects beyond the immediate vicinity of the volcano. These eruptions typically result in low ash plumes and the release of a relatively small volume of volcanic material. As the VEI level ascends to 3 or 4, eruptions become more explosive, producing taller eruption columns. The quantity of erupted material also increases, potentially leading to the formation of pyroclastic flows, a rapid flow of hot ash, gases, and rock fragments. Such eruptions can have substantial regional impacts, influencing air travel, agriculture, and local communities. Once the VEI level reaches 5, eruptions attain a significant scale, characterized by substantial ash plumes and widespread distribution of tephra. The impacts extend over a large area surrounding the volcano, causing disruptions to transportation, infrastructure, and the environment. This is where the situation transcends the immediate vicinity of the volcano and assumes a highly serious nature. At the uppermost range of the scale, specifically levels 6 to 8, lie the super eruptions. These are exceedingly rare and catastrophic events, distinguished by the towering eruption columns that extend into the stratosphere. The quantity of erupted material is vast, and the consequences can be global, influencing climate patterns and resulting in profound environmental and societal impacts. This highlights the immense significance of resources such as the Volcanic Explosivity Index, VEI. By utilizing the VEI, scientists can classify and compare volcanic eruptions based on their explosiveness, enabling the estimation of potential hazards and impacts. This scale aids in comprehending the scale and severity of volcanic activity, thereby enhancing preparedness, hazard assessment, and mitigation strategies in volcanic regions worldwide. During their discussion, Neil deGrasse Tyson and Janine Krippner tackled the formidable challenge of amassing an enormous volume of magma in a single location, a pivotal factor in triggering a supereruption. They emphasized that this process is inherently intricate and time-consuming, requiring the gradual accumulation of magma beneath the Earth's surface over an extended duration. This concentrated reservoir of magma sets the stage for potential supereruptions. Drawing upon their expertise, Tyson and Krippner shared a significant observation concerning the composition of magma beneath Yellowstone. To initiate an eruption, a higher proportion of liquid magma is crucial. Their analysis indicated that a minimum threshold of 30% liquid magma is necessary to establish the conditions conducive to an eruption. In the case of Yellowstone, it already surpasses half of that threshold. All indications point to the possibility of an explosion occurring much sooner than anticipated. And if it does happen, the consequences could be devastating, potentially affecting everything in its path. Supereruptions have the ability to release vast quantities of volcanic ash, forcefully propelling it high into the atmosphere, reaching astonishing altitudes of up to 80 miles. The dispersion of these ash particles over extensive distances can yield significant ramifications for global climate patterns. When volcanic ash is injected into the upper atmosphere during a supereruption, it undergoes intricate interactions with air currents and weather systems. The minute ash particles can remain suspended in the air for an extended duration, distributed across vast regions and even continents by wind patterns. As the ash disseminates throughout the atmosphere, it coalesces to form a dense cloud that can absorb and scatter sunlight, giving rise to a phenomenon known as volcanic winter. The presence of such a condensed volcanic ash cloud can substantially diminish the amount of sunlight reaching the Earth's surface. This reduction in solar radiation can have profound effects on the planet's temperature and weather patterns. The ash particles act as a barrier, reflecting incoming sunlight back into space and inducing a temporary cooling effect on the Earth's surface. This cooling effect can bring about alterations in rainfall patterns, modified wind patterns, and disruptions to regional and global climates. The consequences of this global cooling can have far-reaching implications. Agriculture and food production may be impacted due to changes in growing seasons and decreased crop yields. Ecosystems may face disturbances as species struggle to adapt to the altered conditions. Moreover, the cooling effect of volcanic ash can have repercussions for human societies, potentially resulting in economic challenges, scarcity of resources, and social upheaval. Not only that, but the experts also delved into the disruptive consequences of volcanic ash on air travel, highlighting its potential hazards to aircraft engines and flight operations. They stressed the peril of encountering volcanic ash during flights, as the minuscule abrasive particles can inflict engine damage and impair visibility. This poses a significant safety risk for aviation, underscoring the need to monitor volcanic activity closely and issue appropriate flight advisories during eruptions. Furthermore, Neil deGrasse Tyson and Janine Krippner shed light on the pivotal role fulfilled by the Yellowstone Volcano Observatory and other organizations in actively monitoring the activity of the Yellowstone supervolcano. They emphasized the significance of implementing a comprehensive monitoring system capable of detecting and analyzing various indicators of volcanic unrest, thereby providing critical information for scientific research and public safety. The observatory employs an array of additional monitoring techniques, including measurements of ground deformation, analysis of satellite imagery, and thermal monitoring. These methods assist scientists in tracking changes in the shape and movement of the Earth's surface, identifying areas of heat and thermal anomalies, and offering further insights into the dynamic behavior of the supervolcano. If they fail to carry out their responsibilities effectively, everything falls apart. Unlike super eruptions characterized by their scale and lava composition, large flood basalt volcanoes, occurring over millions of years, involve the eruption of vast volumes of fluid lava that can blanket extensive areas, forming massive volcanic plateaus. Although flood basalt eruptions can have long-lasting impacts on regional environments, they differ from super eruptions in terms of their explosive nature and global ramifications. However, the media often tends to sensationalize the risks linked to an eruption in Yellowstone, often exaggerating the potential dangers. It is crucial to rely on precise scientific information and assessments provided by volcanologists and authoritative sources. Now, we'd love to hear your thoughts. Feel free to share your opinions and insights in the comments section below.